Thank you all for coming today. Sorry for the technical delay there. The new Macs have the USB-C port, and I don't always remember to take the HDMI converter, and it's kind of pain to find them. Anyways, all right. So what are we doing today? I am a big Lord of the Rings fan as well as a Star Wars fan, so I like to theme my talks after one or the other. So this is really about open source and really about the power of open source and what you can do with this. And this is a good example we can talk about with census data. All right, so who am I? I'm Ian Brooks. I joined Hortonworks almost 3 years ago. Prior to this, I was getting a PhD in computer science. I've been a software engineer for a couple large companies. I've also been an information architect. And at Hortonworks, I was leading our data science SME team. But today is not a lot of data science talk today. All right, so what are we looking at and what are we talking about today? So today's Census. So Census is a customer that we have legacy on Hortonworks now with Cloudera. And I think you guys are pretty familiar with what they do. When I started working with them, though, one of the biggest things I thought was interesting, I thought only they put out a census every decade. Really, they have over 160 different survey groups. So you've got a lot of different people actually creating a lot of different reports, and with that, they actually produce some open data. So why really, though? So an agency, though, why would they look at open source? So off the bat here, cost. The adoption of taking open source software allows you to get away from legacy licenses and the way that proprietary companies would do that. Another advantage of open source, in this case Apache Hadoop, is that you get data locality. So one thing I noticed at Census we've seen is they've got many distributed data sets. So actually having them in one place is really valuable to them. And then another reason you could be interested in open source, in this case, improved performance. So using Apache Spark, using in-memory processing, as opposed to a much more legacy I/O-bound type of computing, can actually give you tremendous performance gains. And even some groups I've spoke with, like up to 45 hours for processing time to create their reports. We can do better. And then one of the other reasons you might be interested in open source is talent recruitment. One thing we've had conversations with is the people that are coming out of school now, the people they want to recruit, they don't necessarily have the skills that's in these legacy proprietary tools. They're coming out with skills in Python and R and the things that we look at today. So taking advantage of new talent as well is another reason you might be interested in open source. All right, so the couple of reports today, this is a couple groups I've had conversations with. We have econ, and this is more commodity flow survey, so transportation data, shipping, things of that nature. And then it's SIP, which is a survey of income, program participation. This is more demographic information on individuals and people, on actually who's using what services. The methodology is pretty straightforward. There are open data sets on the Census website. I'll actually point out some of them today. And then with that, there are reports that are tied to that. Those reports have a methodology that describe how the tables get created based on the open data that we have. So really the goal today is to bring those data sets into our platform and then basically using the methodologies reproduce the reports. So I don't have the SQL statements, I don't have the statements that I need. I have to go back and look at the table and understand what that table is presenting and how I could reproduce that. And then of course, display the charts, and we'll do that with some tools today. So to do this, I'm using Apache Spark, really is the main engine for this, and then Apache Zeppelin for the presentation aspect of this. So what I'm going to do is take CSV files, so flat files, I'm going to put them into a data frame, and then using Spark SQL, I'm just going to run SQL statements on top of that. And then using what you get with Zeppelin, some of the native chart capabilities, it'll be presented in a way that's pretty friendly. All right, so before I get to results, let's walk through a couple of the notebooks here. So I've got two of them here. So we'll walk through these and we'll go back to results and talk about this a little bit. So this is, I've got two notebooks. If you guys are familiar with Apache Zeppelin, it's a notebooking tool that we have legacy on HTTP from the Hortonworks side. It's very similar to Jupyter Notebooks if you're familiar with those. What's great is this runs on top of our platform. You still take security and governance into place. You're not even moving the data off of the cluster itself. You're actually just using this as a shell to push the processing down and then review the results in this case. And then, as I mentioned before, Zeppelin has some really nice native charting capabilities. All right. So with this one, I just give you some instructions, information where the data set comes from as well, and so a description of this. I had to go through and understand what these things are saying based on the reports. This wasn't quite put out like this, so I like to make this a little easier to understand what's going on. And then there's a number of column descriptions. So within the tables themselves, they use these characters or these types of descriptions of what's going on. So I have it all kind of all in place so someone can read this and easily see this. So simply, right here, I use the shell interpreter, which is this sh piece here. So in Zeppelin, I can actually call the shell command. So in this case, I'm actually downloading the data sets directly from my GitHub repo, but originally from the census site, and I'm just pushing them to the cluster. So now I have the data brought in, and I'm pushing back to the cluster in one place, which is really great. And then I'll use another shell command just to make sure that they're there, so you can actually see that they're there. Following this, I need to, in this case, this is where I will upload them to HDFS. So now they're on our distributed file system at this point. And once they're on your cluster, you have access to using a lot of tools, in this case Spark, but you could also access these in Hive as well, and different other tools as well. All right. So if you're familiar with Spark, you need to initialize a Spark session, initially after Spark 2.2. Spark session, it wraps around a Spark context, so you've got application names, you've got configurations that go with this, what cluster it's connecting to, some different information that you tie to this. But what's really great is you can put this all together for one application. So you could have multiple Spark jobs with different configurations tied to them. All right, so this is where I'm going to load the data file. And if you look on this line, there's a few things. I've actually got to define this as a CSV file using Databricks' actual library, but it's part of the new version of Spark anyway. I'm telling Spark that there are headers tied to this file on the CSV file, so you actually know that. So it infers that. And then one of the great things I think about Spark is I can tell it to automatically infer the schema of the data set that I come in with. This is really valuable because if you don't have this tool, you have to tell it that column 12 is an int, column 13 is a string, whatever the case might be. So what I really like about Spark is the ability to just tell me what do you think the schema is. And 9 out of 10, it's correct. It's pretty great. It'll struggle on timestamps, but things like that can vary based on format. And then you can see right here, this was in fact a CSV file sitting out there. So just a nice little flat file. So basically, I can grab a flat file. I can tell it there's headers, infer the schema, push it to a data frame. And once I have it in a data frame, one of the nice things about Spark is I can now treat this like a temporary table. So this is where you can actually run SQL statements against this and not really know what is actually behind this. And it's one of the great things about Spark that it gives you. And then I'll print out the schema so we can verify this. So there's a number of tables here. I repeat the same process. And then you can see what we end up with. Here are the tables. So think of this as because this is coming out of a kind of a relational database kind of model, I've got to reproduce that connection to those things. So when I want to do SQL across multiple tables, I can understand how they connect to each other. All right, so I go through a pretty good merging process here to make this a lot easier to read. Mostly because if you don't, then you don't get Massachusetts, you get like a state code, for example. So it's a little easier to read. But based on things I've described, so using just a big join, now I have these tables that are virtualized, and I've got them joined together, and I can just run SQL against them. It's the same kind of things here. All right. Let's see. So these are some of the tables that are actually in the report. So let's keep looking at some of these. In this case, it's shipping by modes. You can get some ideas. I've actually got some prettier charts here we could look at. And it shouldn't shock you, trucks. I think trucks are constantly popping up. If you think about shipment and moving of goods, I think most of it comes on a large truck, and the data here is confirming when we think that. By tonnage, it shouldn't shock you guys. Trucks again, for hired trucks, for example. Different transportation per miles, different types of things that we see here in the reports, but these are actually matching exactly the reports, and I've got the table topically titled here. So if you go to the report, the data will look the same, except it'll actually probably look like that. So one of the nice things about Zeppelin is I can easily switch between how I actually view that information back to me. So it's a little more interactive than just a PDF, I think. And again, some more classifications of goods here. So you can start to see what types of goods are out here based on tonnage, based on just the count of the shipments, based on value. So when I think about census, like I only thought they really took information on people, but it's really a lot about everything we do in this country. And they really are the arm of collecting this information that can be used by other people. All right, put that one there. Okay, now with SIP, it's a very similar process. The difference with this one, though, is it's got a fair amount of columns that weren't defined for me. So I had to go in and actually define these out, and if you can see, it's a pretty extensive list from the structure type. This data set is a little bit different because there's what they refer to as waves, so they can take the same survey and they can do it multiple times against the same threshold, the same households, and then you have to effectively figure out what's the most recent survey on that household. Then you're not counting that household twice, so it becomes a little more interesting. And as well as this is a really wide table. I think you can see how many columns we're talking about. Pretty wide table. I'm going to minimize that. So similar process we did before. I'm taking the flat file in, I'm inferring the schema automatically, pushing it to a data frame, and then I'm going to make it a table, the same thing we did before. So I've got to go through a union process the same way. But what really you're demonstrating is, think of this as a relational database in real time, or just in time. So when you actually can define the structure, but not until you actually make a statement against it or a query against it, does it actually build out. But if I was using an existing relational database, all this would be there persistent. So when I'm grabbing these data sets to reproduce the SQL statements, you need these ultimately. So wave 10, we get some more charts are coming up. Okay, there's some. All right. You can see some more information here in bachelor's degrees. I don't really want to break all these down, but the information is correct. I have a few screenshots to demonstrate this. So let's go back to the talk here. Okay. So for the first group here, we're going to have a screenshot for table 1. We're describing this. Now, the methodology that it describes this will explain what these columns are from census, but they're not giving me the SQL statements. So I did have to look at this, understand what these are, and there's actually a logarithmic piece to one of these when they're doing some estimates. I had to go back and reproduce that. And so that's something, but it's really cool about Spark is just put that in the SQL statement. Well, you can see the values, the values match there for B1. And then another great thing about this is now, instead of just a table, I can give you these really interactive charts that are really colorful. It can actually tell you more of the story than just looking at a table. And then with SIP, we're looking at one table because there's so many of them. In this case, it's RH type. And that might be really hard to read, but the numbers are the same, actually. They do actually match up as well. All right. So this is a really quick conversation on why you would do this. But the biggest values, if you think about this demonstrates that using open source tech, you can get away from legacy proprietary software. And you can do it in a way that still gives you performance gains. It gives you opportunity to recruit new talent, which is what you want to be looking at to keep your agency moving forward. And as well as you can get away from licensing costs, which for some agencies is really important. It's something that we like to help our customers do. So thank you all for coming. Are there any questions? Again, I know it was really quick, so we have plenty of time for questions.
You said you had to reproduce, is it because there were subcategories of the buildings? You were saying that sometimes you have to reproduce on the CSS.
The queries or the table structure?
Yeah,
so I had to make the queries based on what the table looked like, but to get the displays to be the same, like to get California, Massachusetts, I had to rebuild add the tables back together. So like state 25 was Massachusetts, right? So I could print them out on one line. Because otherwise you could just use the one table, but you're not getting the codes for the city or the state, for example, in that case. Yeah.
Like along those lines, because it has so many, like I've done a lot of the census data, it has a lot of different subcategories, keep going.
Yeah.
Could you do that for SQL? Like, could it figure it out, or you had to
I think what I did in the other one, what I did with SIP, where I defined the structure, like that's what you'd probably have to do. Then you could have embedded, like nested structures underneath that, and then you could query that with like a dot. I mean, you sort of like can break to that substructure with a query. Yeah. Good question though. Any other questions, guys? Is anyone curious what the legacy software was? I hear you out there. Yeah, SAS. SAS is most definitely what we're talking about. The thing about SAS is I think it's expensive for what it is, and I think it's antiquated. And when you think about where they're going with their next architecture for memory processing, it's expensive. I don't want to quote what it costs, but go out there and ask what SAS Avaya costs, and you'll be very surprised, like I was. So Spark being completely open source, you basically get the same performance for free. Not quite free, but open source.
What the license costs versus what the license costs to implement are two different things.
Will you still?
Migrate from one version to another.
Yeah, I mean, there's going to be some rewrite here as well. You got to dedicate time to train your folks up on this.
The problem that I think public organizations that have used and in healthcare is used quite a lot SAS, like health departments and stuff like that. The problem is that there's so much legacy code in SAS that even though we're evangelizing the fact that they should use Python and R because the new generation, that's what's being taught. They're not being taught SAS anymore like 20 years ago. They have a hard time shifting because of the amount of work that has been done, and retrofitting all of that is almost impossible. So that's the challenge that they're having.
Yeah, and that's something conversations I've had with a couple groups at Census. Literally, Econ had a 9-page flow chart that produced all their reports. And I just said, why even go through that process? Why can't I just start, give me the raw data and give me what the tables look like, and I'll make a new process. So it is a rewrite. I mean, yeah, very much it is a rewrite, acknowledging that, but the advantages that you'll get, I think, are long-term for your agency. It's a good time to step away from it. Good question. Terry. No, I mean, I did it all in Zeppelin, but you could use CDSW as well. I mean, I actually have this. I have a GitHub repo for both of these, and I've got one of them converted for CDSW, but I haven't got all the charts quite cleaned up yet. I've got a little more experience with Zeppelin. I'm still learning CDSW's charting capabilities, so yeah. I'll have it for you guys, don't worry.
Do you have them available for?
I do, yes, I do. Gotta love putting your password in front of a crowd. There we go. But yeah, I have them on my GitHub repo, which is it's just Brooks Ian, and then this one's out here. I gotta get SIP on there, but I do have. You can see I've got the Python. I've got the JSON's the Zeppelin notebook. Python is the equivalent for CDSW. The Scala code is also the equivalent for CSW as well. Sure.
So, coming from public sector, my question would be, how do you get the buy-in from the leadership to use open source software to begin with?
Oh, it's Census? I just did this. I was mostly having conversations, and I was getting really frustrated because I couldn't get the SAS code. Like they couldn't give it to me for legal reasons, which I agree with. And I saw these flowcharts, and I honestly was frustrated. I was like, I could do this in Spark, and I just did it. That's really the why.
Public sector is very pro open source from a development model. Customers like Census would go with a support subscription, so it's viewed very much like a commercial off-the-shelf product harnessing open source.
Yeah, not so much on my information. So I've tried to use it, and I've been pushed back saying, don't do it, just use whatever is legacy in-house. To your point, it's a waste of time.
I don't agree with that process. Do whatever we've always been doing, or we could try something new. So.
So Ian, how long did it take you to develop what you showed here?
Good question. On the econ one, on this notebook, this one was pretty straightforward because the table structure is pretty basic. You're only talking like 5 tables, and the joins are, once I got the merge statement figured out, it was more about displayability. So getting, again, like Massachusetts to be there, not like 25. On SIP, it was a little more challenging because of the waves, because they do the same survey multiple times on the same household. And then I wasn't always sure if like household 1 was the same in wave 2. So I had to kind of decipher that a while. So this one took some more time. And then also, I mean, the number of columns I showed you guys, like I probably spent an hour or probably an hour just doing like copy and paste, and like getting it all cleaned up. So this one took a little more time. But like the waves are what are strange about the one, because you have weird, strange cardinality rules. So I had to kind of figure that one out, and I actually had to do a select statement on a where clause, which was an interesting query. Let's see if I can't find that one. Yeah, I had never quite done that before. A select on a where clause. So that's how you can match up different ones when you query through them. So.
Just follow up on Christine's question, how long did it take you for not really knowing the data, not really knowing the structure or anything like that? 8 man hours?
Yeah. Yeah, I mean, the first one was probably a couple hours. This one was probably a day. I probably spent a whole day just doing this, but it was. But again, like the cardinality was hard. If I had got a chance to sit down and had a more conversation, it was peers group, a little more conversations about this, I think I could have sped that up a little bit. So knowing the data is really important, obviously.
I'll follow up on that one too. So how long organizationally, how long would you think a shop like that had legacy software, legacy processes and everything like that, how long would it take them to get up to speed? Obviously you're a data scientist, data Jedi up there, and you know what you're doing with some of these tools, but with training and everything like that, what do you think the time frame is for organizations to adopt something like this?
I mean, assuming the cluster's in place, their data's all in place, and all that's in place. I mean, I think realistically that each team owns their own surveys, and they know their data better than any of us do. So having that domain expertise would be really valuable. So I think you could do this in weeks. I don't think months, but maybe months for the whole process. But weeks, I think, would be a realistic expectation to prototype things out, right?
So what happens if you don't know the actual data? Suppose you get third-party data, you get it done.
Obviously, it would depend on what you're looking at. I mean, for me, because I sort of do that, I sort of like look at data that I don't know a lot about. So I have a lot of experience in doing that, but you kind of have to trudge through it. There's a little bit of a discovery process when you don't know what exactly the data has or what's in it. So you've got to figure that out, and it does take some time.
Is that a manual process, or is there other tools?
I mean, you could use data profilers. You could profile from different things like that. I would. Tools like this. I wouldn't quite call this manual, but I would put it into a tool like this and start to look at everything that's in it and try to understand what the data is actually telling me. So I mean, it's going to depend on the experience of the person doing that, and if they can decipher what that data is telling them quickly, it wouldn't be a challenge. But if it's completely cryptic, it could be really hard. Maybe an intern with maybe a couple interns.
How big was the data set that you pulled in?
Good question. They're under gigabytes. I mean, what they are. I mean, one of them's probably, and I think SIP was like megabytes. Econ was a bigger data set. But on our platform, it doesn't matter. I mean, these things, like this whole thing will run, and once I've got it all like ready to run, it'll run in a couple minutes, and it's really fast. So I think when you talk about Apache Spark, the great thing is it is distributed parallel processing, and it doesn't really matter how big your data set is as long as you've got it distributed in the right way or enough nodes to participate, and you can get really, really great performance out of it, as opposed to using a single server to do this. But this is why we Hadoop. This is why we use things like Apache Yarn. Sure.
Any suggestions for like mapping that's more open source, like mapping this data?
Onto like a physical map?
Like, you know how like you can kind of get expensive software to map it all out, right? Because a lot of this is geographic data.
Sure.
So is there any suggestions for kind of like
Yeah.
that
You can
besides, like,
you can do a lot of there are plenty of mapping tools out there. Hold on.
kind of open source or
Yeah, assuming it's not broken, I might have one for you. I got to rerun this one. Okay, so give me a second. Maybe I can have a map for you here in 1 second. I just kind of have to get a couple things started. So this is our team cluster. It's been limping lately. We've been just kind of putting fires out, so I'm not always sure if things are going to run as I expect them to. But I've got a map in here. So this is EPA data. This is EPA air data. This group is completely, obviously very geospatial. These are all sites basically that have this, and then make sure I get the main data set. Might have this one here. Query the table. Let's do this. Okay.
And while you're getting this set up and running, could you use this as a data source to feed into to Esri or ArcGIS tools or anything like that? Maybe ArcGIS Online.
Yeah, I mean, you could definitely use APIs. You could write it to a Hive table, and it could be an intermediate. You could probably push this, if you have a JDBC connector, you can configure Zeppelin to communicate to that. So there are ways to push the results to something else if you wanted to. Good question.
So while you're doing that, I have a question.
It'll go here. Well, just fingers crossed the thing doesn't catch on fire right now. Like I said, this whole server we're having some issues with.
So Ian, I know you use public data here. What happens if you're using encrypted data? What is the performance?
So whatever, I mean, it's a good question. I haven't thought about using encrypted data, but whatever the latency is to unencrypt it for the processing would be that. And it wouldn't be terrible if it was distributed because you've got concurrent reads going across it. It wouldn't have to convert every piece of it on one link. You could have a lot of data sets being converted concurrently on the read side. So I guess it's a quick question. I don't know. That would be the best way to answer that one. All right.
Well, I guess I would like to extend it. I'm not talking about encryption from storage. I'm talking about encryption while in motion.
While in motion.
Those different clusters. And, there are lots of customers who have PII data. They're putting it in cloud environments which are not owned by us. We have to protect the data. So the question is, how are you encrypted? Or if that is encrypted, you just came out of a session, what would happen in this process?
I mean, you're going to have to, you have to go through a decryption process at any point you'd want to process it, unless it's something that could be used in that state, like just, maybe it's a hashing technique or something like that. Maybe you could get by without having to decrypt at that point. Let's talk after. I might have to bring Terry into this one.
That's why the mapping question led to it, because that's privacy issues for at least some of us. So the question is, how do you handle it?
Well, let's talk after. I'm gonna have to think about it. So I've lost my Angular interpreter. This is.
The platform deployment, usually you put Knox like in front of this, and Knox handles all your, all your edge security, and then you can reach Zeppelin through Knox. It has a proxy. So, but behind the scenes, you
you're talking about how long it takes to run your job, it adds an overhead. And, you know, wild guess, depending on what you're doing, maybe 10 to 40%, but it's linear and scalable platform, so you add no nodes. But it is an overhead, it's possible.
If the data can never be decrypted and still needs to be computed,
It's possible.
then there's
Just
homework and
looking
computer
for
solutions.
end result.
Kind of. But that's not really, yeah, it's very expensive.
Cost is sometimes balanced with the risk.
Okay. So for some reason or another, my Angular interpreter is just not on. So you can put like I said, a map here. I would be curious to what will happen if I would probably lose this map. But so you can embed leaflet maps. Anything that's like JavaScript, you can actually embed in using Angular. And then I will populate that. But again, I don't know what's going on with our cluster right now. Like we're going to rebuild this thing next week, so it's kind of at the end of its days right now. But you can embed that. There are other. I mean, but I will be honest with you. You'd be better off pushing, having a BI tool actually pull out of something like that, a repository you write to, or maybe Spark SQL or something like that. Yeah, yeah. Sorry guys, can't show you the whole thing.
This example, you uploaded CSV files to your server. Does Spark have the capability of doing an ODBC connector to a different device?
Yes. So, how would we configure? John, do you know how we would configure the ODBC connector for Spark? I'm trying to think.
Question to have Spark reach out to something, or to
Yeah.
use ODBC?
To pull data from a different server.
Yeah, I mean, yeah. So you can, and then in Zeppelin as well can also communicate using a JDBC connector too. I guess I'm trying to separate Spark and Zeppelin in this case. Yeah. There are definitely ways of doing that.
Another workflow would be to bring the data from CSV into Hive, and then, and you can do that through many ways.
Yep.
And then use Spark on top of Hive.
Yep, and if you did that with Hive being persistent, then you could point other things at it as well. So you could get access to it with other tools as well, yeah. It was a short talk, guys. I mean, it was more of a philosophical conversation, I think, but I didn't really want to bore you with SQL statements, so nobody really wants that. Thanks, guys.